Alright, so for this video lesson, this is going to be the last topic of chapter 4. So we're going to do 4.5 and 4.6. This is going to be solving radical equations, okay? So we have solved equations before, back in our first couple units, okay? When we're solving these, we're either finding like the intersection points of two different functions, or we are also looking to find the roots if it is just one function, okay? So just a little bit of a review. So we can solve equations involving square roots and cube roots using inverse operations. So if you have a square root, let's say we have the square root of 3 is equal to x, right? If we wanted to, well, let me back up. Let me do that the other way. Okay, so if we have the square root of x is equal to 3, then to solve for x, we would square each side. So the square, or root x times root x is just going to be x. So that if we square a square root, those terms will cancel. And then after you square that, we'll have x equals 9. Okay? Same thing if we had like the cube root of x is equal to 2. Okay, same thing here. We would just cube each side. The cube root and the cube cancel. And then once we cube 2, so 2 times 2 times 2, x is equal to 8. Okay, so if you have like the cube root of x or the square root of x, we can just either cube it or square it to get rid of that root. Okay, so let's get into a problem here. So a sprinkler sprays water as shown below. What is the radius of the water? So we're asked to find the radius if the total area covered is 2.25 square meters. Okay, so go back to our grade 7 math. Area of a circle is equal to pi r squared. Okay, so if we know our area, and of course we know pi, we just need to simplify this or write it in terms of r, right? Right now it's a equals pi r squared. We want it so it is r is equal to whatever, okay? So first thing we need to do, so when we're simplifying equations, it is the reverse of BEDMAS. So remember BEDMAS, brackets, exponents, division, multiplication, addition, subtraction. We're going to do the opposite operations when we're simplifying, okay? So we're going to divide by pi on both sides. Pi divided by pi, or any number divided by itself, is just 1. So we get rid of that. So now we have area over pi is equal to r squared. Okay? We do not want to know what r squared is. We want to know what r is. Okay? So let's take the square root of both sides. So if you take the square root of r squared, we'll just have r. Okay? So then we can write our equation in terms of r. So we get radius is equal to the square root of the area divided by pi. Okay, we know our area is 2.25 square meters divided by pi. You can just use 3.14. I honestly don't remember if I used pi or 3.14. I'm okay if you use either. You guys have the pi button on your calculator, so you should use that. Just gives us a more accurate answer, right? Okay, so you punch this into your calculator and we'll get a radius of 0.846 meters. Okay, radius is only in one dimension, so it is not meters squared. Okay, so we just did a little bit of algebra there, and we were able to solve for our radius. Okay, now if we are asked to solve the following radical equations, we are trying to find the values of intersection point, right? So we're trying to find where 5 root x and y is equal to 35 will intersect. Okay, but first let's do our restrictions. So let's look at our x. Okay, we're taking the square root of x. It is x to the 1. So it is an odd exponent. Therefore, x must be greater than or equal to 0. Okay, those are our restrictions. Now, let's go ahead and solve this graphically. Okay? Now, just before you guys enter this into your calculator, set your window. We want your x max to be 60 and your y max to be 50. If you're using Desmos, of course you don't need to set your window, but make sure you know how to use your calculator, right? You won't get Desmos on the final. Okay, so let's solve this graphically. So we have 5 root x is equal to 35. Okay, so to solve this graphically, let's make our y1 equal to 5 root x, and our y2 can be 35. Okay? So put those into your calculator. Okay? Our y1, 5 root x, is going to look something like this. Okay? And our y2 will be in red, is going to look something like this. Okay, and of course that will go both ways. And we are looking to find the intersection point. Okay, so on your calculators, to find that intersection point, you need to go second and then trace, which is your calc button. Okay, and then you want to go to number 5, which is your intersect. Okay, so that is how you will enter that and solve that on your calculator. So once you do that, you will get an x value of 49. Okay, so this point here, x value is 49, and the y coordinate is 35. Of course. Okay. Okay, so our x equals 49 here. That is where those points intersect. Okay, that's graphing, so let's go ahead and solve this manually. So when we solve it manually, we're going to set 5 root x equal to 35, and we are going to solve for our x. Okay, so what's attached to our x? We have 5 root x. So let's divide both sides by 5. Any number divided by itself is 1, so that will go away. Now we're left with root x is equal to 35 divided by 5, which is 7. Now, to solve for x, okay, we need to square both sides. Square root, and the squared cancel. We're left with x is equal to 49. Okay, so there's 2 different strategies to solve these types of equations. Okay, just make sure you're able to do both and recognize what I'm asking you to do when. Okay, so we have a few more examples like this, so I would encourage you to pause the video and try these on your own. Okay? So, for this second one, so we have the square root of x plus 2 is equal to negative 3. Okay, so let's set our restrictions here. So remember, we cannot take the square root of a negative number. So x plus 2 must be greater than or equal to 0. Subtract 2 from both sides. We find that x must be greater than or equal to negative 2. Okay, those are our restrictions. Okay, And let's go ahead and graph this. So my y1 is going to be root x plus 2, and my y2 is going to be negative 3. Okay, so y1 will be in red. And what does this look like? It starts here and goes to the right. Okay, and my y2 is going to be in blue. That is negative 3, so it's going to go below the x-axis. And now we need to ask ourselves, do these lines ever intersect? No, they do not. Therefore, no solutions. Okay, so we just solved that graphically, but let's confirm solving this manually. Okay, so we have x plus 2 is equal to negative 3. Okay, so let's solve for x. So we will square both sides. And we get x plus 2 is equal to 9. Subtract 2 from both sides. X is equal to 7. Okay, so we actually do have a solution. It says that we have a solution here, but to check, let's sub this into our original equation. So root of x plus 2 at x equals 7 equals 7 plus 2, which is equal to root 9, which is equal to positive and negative 3. Okay, so this might suggest that we do have solutions, but in this particular question, we do not. Okay, so it's actually wise for us to both check it graphically and solve it manually, right? All right. So for our next one, we have root of x minus 1 plus 3 is equal to 4. Okay, so let's find our restrictions. Remember, whatever is underneath the radical must be greater than or equal to 0. Right? So x minus 1 must be greater than or equal to 0. Add 1 to both sides. We know that x must be greater than or equal to 1. That is our restrictions. Okay, so now let's go ahead and solve this graphically. So my y1 is going to be root of x minus 1 and plus 3 is outside of the root. Okay, and my y2 is going to be 4. Okay, so you guys are able to use your calculator here. Okay, to graph, of course. So there is my Cartesian plane. My y is equal to 4. Will be up here. And my y1, my root of x minus 1 plus 3, is going to start here and go to the right. Okay, so we do have an intersection point here. We do have a solution. Okay, so again, go and use your calculator for this. You go second trace, which is the calc button, and then you want to select number 5, intersect, and to find our intersection point. Okay, so if we do that, we will find our intersection point is at 2 and 4. Therefore, our x is equal to 2. Okay, so the value when x is equal to 2 will satisfy this equation of root of x minus 1 plus 3 is equal to 4. Okay, let's go ahead and solve this manually now. So we have root of x minus 1 plus 3 is equal to 4. We're solving for x. Let's subtract 3 from both sides. Now we have x minus 1 is equal to 1. Square both sides. We get x minus 1 is equal to 1 plus 1. X is equal to 2. Okay, which is great because that's what we saw when we were solving it graphically. So it is important that our solutions do match one another when we're solving it graphically and manually. Okay, 2 more to go for today. So here we have a cube root of 2x, and that is equal to 4. Okay, so let's set our restrictions. X is to the 1 here. Okay, so our restrictions here should be what? X should be greater than or equal to 0, right? That's if it's a square root. Okay, when we're taking the cubic root, it is a little bit different. Okay, so I'm going to let you guys graph this first, and we will see if we have any restrictions on this function. Okay, so when you set your window on your calculator, we want it at x max 40 and y max 10. Okay, and our y1 is going to be the cube root of 2x, and our y2 is going to be 4. Okay, so let's make a little graph here. So my y2 is equal to 4. Okay, and what does my cubic function look like? So I'm going to do this one in green. And is what it looks like is something like that. That was actually pretty good. Okay, so we do have an intersection point right here. So again, use your calculator. Second trace, number 5. Find our intersection point. We get an x value of 32 and a y value of 4, right? Of course, because our y is equal to 4. Okay, so we know x is equal to 32. But let's confirm and let's check by solving manually, okay? So we have cube root of 2x is equal to 4. Now to get rid of that cube root on our 2x, we can cube both sides. Cube root and the cube will cancel. Now we're left with 2x is equal to 4 cubed. So 4 times 4 is 16. 16 times 4 is 64. Now we'll divide by 2 to get x by itself, and we get a value, x is equal to 32. Okay, so again, these solutions match, which is good. And let's return to our restrictions on this function here, right? It does not look like our cubic function is going to end anytime soon, and cubic functions generally always have no restrictions, or the domain x is a set of the real numbers. Okay, it will go left forever and it will go right forever. Okay, so no restrictions on this function. Okay, if it's a cube root, typically it is always going to look like this little kind of swivel. Okay. Alright, so we get a word problem here. So we have somebody swinging on a swing. The forward and backward motion can be modeled using the formula. T is equal to 2 pi times the square root of the length divided by 9.8, which is the acceleration due to gravity. Okay. So in this formula, T represents the time in seconds for the swing to return to its original position. L represents the length of the chain, which is in meters. Okay, so that's a little bit of a setup. Now in this particular problem, we know the time. So it took Kara, I should use big T for that, 2.5 seconds. And we are asked to determine the length. Okay, so right now our formula is written in terms of time, T. We need to manipulate this so it is written in terms of L. Okay, now to do that, so we got to get rid of that square root first. And what we're going to do, we need to square everything. Okay, so we're going to square the 2, we're going to square the pi, we're going to square the t, we're going to square the square root. Okay, but when you take the square of a square root, that cancels. So we are going to be left with t squared is equal to 2 squared is 4, and pi squared is pi squared. So 4 pi squared times L divided by 9.8 now. Okay, so let's divide each side by 4 pi squared. Those will cancel. Now we're left with t squared over 4 pi squared is equal to L divided by 9.8. The last thing we need to do here to get L by itself is multiply both sides by 9.8. Those will cancel. And now our equation is written in terms of L. So L is equal to 9.8 t squared divided by 4 pi squared. Okay, we know our t. It was given in the question, right? So our t is 2.5 seconds. So let's go ahead and substitute that into this formula. So 9.8 multiplied by 2.5 seconds squared divided by 4 pi squared. Okay, just be careful that you only square the 2.5. Okay, we do not want to square the 9.8 as well. Okay, so punch those into your calculator carefully, and we will get a length of the chain to be 1.55 meters. Okay, how do I know it's in meters? Well, 9.8 is the acceleration on Earth, which is meters per second squared. Okay, so I know this must be meters. We want to provide our answer in centimeters. There are 100 centimeters in a meter. So we will get a length equal to 155 centimeters. All right. So that is solving radical equations. All right. So hopefully that was a little bit of a review for you, and we also introduced some new concepts, right? Dealing with radicals and simplifying radicals, right? So your assignment to work on for the rest of today's class time. So so for the next hour and 7 minutes, you guys are going to work on these practice problems, okay? And again, once you've completed your notes and the practice problems, please send me a photo or submit your completed assignment to the Google Classroom. All right? Hopefully you guys are motoring along. And if you have any questions, don't hesitate to reach out. Okay? Thank you. See you soon.